All right, we're going to 9.3, which is just arithmetic sequence. We just talked about both arithmetic and geometric. This lesson, we're going to focus a lot on the arithmetic sequences. So, objective today is that students will be able to use the arithmetic sequence to complete a given set of terms. Now, a series is just a simple sum of terms in a sequence. The fundamental definition or notation is this, what we see. You've been able to see the E, the sigma notation, and it just means the sum. Question says, given the arithmetic sequence defined by a sub 1 is negative 2 and an, this whole thing there, then which of the following is the sum of 5? Now, I know a1 is negative 2. What is a2? a2 by definition it says is the previous, which is negative 2 plus 5, which is 3. a to the third is my previous, which is 3 plus 5 is 8. a to the fourth, my previous, which is 8 plus 5. Common difference is 5. 8 plus 5 is 13. And then a to the fifth is 13 plus 5, which is 18. Now, because I have the sigma notation, that means I need to add these up. So basically what I'm going to do is 3 plus 8 plus 13 plus 18. Oops, don't forget my negative 2 in the front, because I'm going to add all 5 terms up. When I add this, I should get 40, which is choice 2. Okay, so that's a quick review. Now, this is what I really want to look at here. We have exercise 2. Before we go into exercise 2, we must remember that the sum associated with the arithmetic sequence is known as the arithmetic series. Having intersecting properties, many applications and values can be predicted by what is called a rainbow addition, which is what we have right here. This is known as a rainbow addition. So for this question, it says, consider the arithmetic sequence defined by a sub 1 is equal to 3 and a of n is equal to my previous term plus 2. The series based on the 8 terms of the sequence is shown below. Terms are paired off as shown. So notice 3 goes with 17, 5 goes with 5, 7 goes with 13, 9 goes with 11. Now A, what does each pair of sums equal to? 20. Excellent. 3 goes to 17. Basically, 3 plus 17 is 20, 5 plus 15 is 20, and so forth. Why does it make sense that the sum is constant? So it makes sense. Why? Because only one term is increased by 2, and then one is also decreased by 2. So you had it right here. Now, one of these terms increase by 2, and the other decrease by 2. Okay, so if I'm going this way, I'm adding 2, come back this way, I'm subtracting 2. How many pairs are there? Look at this. How many pairs do you see here? So the number of pairs will always be half of the total elements. In this case, it's only 4 pairs, as you can see. 3 and 5 is 1 pair. I'm sorry, 3 and 17 is 1 pair. 5 and 15 is 2. 7 and 13 is 3. And 9 and 11 is my 4th pair. Using your answer from A and C, find the sum of the multiplicative process. All it's asking to you from A and C, what's the sum of the multiplicative process? So it's 4 times. We know this means multiply. 4 times 20 is 80. Now, how can we generalize this to create a formula for an arithmetic sequence sum based on the first term and the last term? So in general, each pair will have the sum of the first and last term. So each pair will have a sum of a1 plus a to the nth. Then the number of pairs will always be half the number of elements. So number of pairs is equal to half the number of elements, meaning half of n, whatever n is. So in this case, in C, there were 8. My n was 8. 1, 2, 3, 4, 5, 6, 7, 8. I take half of that, so this is half of 8. That's how I got 4 pairs. So, what do you think the sum now? Let's write that in a different. So the questions say, what do you think the sum? The sum, S of n, would be equal to half of my pair and my sum of each pair. Half of this number of pair, this comes from here, times my sum of each pair. Now, let's see how that works going on to the next page, which is our equation we just found. It says, which of the following sum of the first 100 natural numbers? So it's saying the first 100, S of 100 is equal to 1 plus 2, blah, 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 all the way to 100. How can I find the sum? So the sum of this is n, this is my n, and follow my definition up here. Half of n, so 100 divided by 2, 1 plus 100, this works out to be 550, which is choice 4. So by definition, what we just found is the sum, instead of saying 1 plus 2 plus 3 plus, oh my god, all the way to 100. Now, what if I say find the sum of these arithmetic sequence shown below? So, again, use your definition. The sum of how many terms do you think we're going to have here? There's 16 terms. Perfect. So again, I'm going to do 16 over 2. Negative 10 is my first term, plus 50, which is my last term. Plug that in your calculator. You get 8 times 40, which is 320. Now it says the first term is negative 8. The common difference, D, is 6, and there are 20 terms. So what do I do now? So I need to find what's this 20th term. I know the first term is here, negative 8, but I don't know what's the last term. We need the last term like this one. So let's do 8 to the 20 would be negative 8 plus, yes, because it's an arithmetic sequence, 19 times the difference. This works out to be 106. So remember, I'm asking for the sum of 20, so it'll be 20 over 2. I know my first term, and I just found my 106. I just found my last term. Put this in the calculator, you get 980. Alright, so C, kind of going a little backward, it says the last term, 812, is negative 29. The common difference, D, is negative 3. How can I find the sum? Well, first of all, I need to know what is my A1. So remember, 812 is actually equal to A1 plus the difference, plus 11 times the difference. 11 because it's 11 times the difference. 11 because it's n minus 1, and this is from definition on the 9.2. So let's fill in what I know. I know this is negative 29 is equal to A1 plus 11 times negative 3. This becomes negative 29 is equal to A1 minus 33. So how can I solve for A1? Add 33 on both sides. Perfect. When I add that, I get A1 is 4. Now that I have this, I can find the summation of 12, which is 12 over 2, 4 plus negative 29, my first and then my last term. This would actually give me negative 150. So remember, to find the sum, you need to know how many terms they are, my first term and my last term. Now one more example, the sum of 5, 8, 11, blah, 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 77. So, what do I know? What do I need to know? My first term is 5, my last term is 77. But I want to know what is my common difference, or what is n? How do I find what n is? So here I was given a 12. Here I'm not. I want to know what is this n. So we can use by definition my last term, which is 77, will equal to 5 because that's the starting, plus what's my difference? Every time I go from 5 to 8, I'm adding 3. From 8 to 11, I'm adding 3. So the common difference is 3, and I want to know what's my term. The term is always 1 less. Remember that? So 77 is equal to 55 plus 3n minus 3. I can go ahead and combine like terms. What am I going to be left with? 77 is equal to 2 plus 3n. Take that over, minus 2 on both sides. 75 is equal to 3n. So that means 25 is equal to n. So it means that I have, let's just get a little space here, means that I have 25 terms. So again, how did I know I had 25 terms? I'm giving my first term. I know I'm giving my last term. I know my first term. I know the difference because to go from 5 to 8, I add 3. From 8 to 11, I add 3. So that means my difference would be plus 3. And it's always 1 less than what I started with. Go ahead, distribute, and solve. I get 25. Now that I know this, I can find the summation of 25, which is simple. 25 over 2, my first term, which is 5, plus my last term, which is 77, and this will give me 1025, and that's it. So in this case, how I was not given 16, I could have done the same exact thing here and solve. One last example before I let you go. Kirk has set up a college saving account for his son, Maxwell. If Kirk deposits $100 per month in an account, it increases the amount by $10 each month. Then how much will he have after 10 years? So he's starting with 100 and every month is going up by 10. How many will he have after 10 years? So what can I do here? Remember the definition. So 10 years, how many months are in 10 years? That's the first thing you need to think. 1 year has 12 months. Therefore, 10 years would have 120 months because it says this deposit go up per month. So I have to find a to the 120. A to the 120 would be my starting 100 plus 119, 1 less than this number, times 10. This will give me 1290. Now what's the sum that he will have after 10 years? So I'm trying to find the summation of 120. 120 over 2 plus my starting plus, what did I get after 120 months? 1200. Work this out. Maxwell is a rich guy. He has 83,400 in his account after 10 years, if Dad does that. Alrighty guys, go ahead, try those practice problems. Good luck!